to gas equation session, or it is also called combination of Boyle's law and Charles' law. So in this session, we will try to cover 4 learning objectives. We'll again revise what is Boyle's law and Charles' law, and then try to combine these two laws, which will give us the relationship between volume, pressure, and temperature. Then from this relationship expressed with Boyle's and Charles' law, we'll try to derive gas equation. And then we'll also practice some numerical problems and solve some questions together. Now, some of the introductory key points. We already learned that volume has an inverse relationship with pressure. That is what Boyle's law expressed. And we have also learned that volume got direct proportional to temperature. That is expressed by Charles' law. Now, Boyle's law states that at constant temperature, the volume of the given gas is inversely proportional to pressure. And Charles' law states that the volume of the gas is directly proportional to the temperature. If we consider the Boyle's law and Charles' law, we'll find that volume is common in both the laws. So let us rewrite both the expression. Volume is inversely proportional to pressure, and for Charles' law, volume is directly proportional to temperature. We're combining Boyle's law and Charles' law. So let's rewrite the expression. Volume is, so T into 1 is going to be T divided by P. Now let us remove the proportional sign by multiplying the right hand side with a constant K. Now let us rewrite the expression by multiplying the right hand side with a constant K. So we will get V is equal to T by P times K. And the K here is our proportionality constant. Again, let us rearrange the equation by sending the P and also to the T to the other side. So P here is in the denominator. So when it changes its side, it will go to numerator. And T here is in the numerator. When it changes the side, it goes to denominator. So we will get PV divided by T is equal to K constant. So this is our formula that we get when we combine Boyle's law and then Charles' law. So in our previous lesson, we obtained the formula, and that is PV by T is equal to K. So to derive the gas equation, let us consider again 2 cases. So initial state and then final state. So let us consider we have a gas inside a container, and then the volume, let's take it as V1, pressure of the gas as P1, and also the temperature as T1. This is our initial state. So when there is change in volume, the pressure and temperature also changes. So let us now consider a final state of the same gas whose volume got changed to V2, pressure got changed to P2, and temperature got changed to T2. So to the first initial case, let us try to express by using P by T is equal to K expression. So for the first initial state, we'll write this expression as P1 V1 by T1 is equal to K. And then for the final state, we'll express this expression as P2 V2 divided by T2 is equal to K. And since we already learned that the proportionality constant k, they are equal to one another, so we can replace the value of k with this and another k with this expression, and hence we'll get P1 V1 by T1 is equal to P2 V2 by T2. Hence this equation is called gas equation. Gas equation is combination of Boyle's law and Charles' law. Now we have derived gas equation, that is P1 V1 by T1 is equal to P2 V2 by T2. So by using this gas equation, let us discuss question number 1 from page number 11. Page number 11. So let me read the question for you. The given mass of a gas occupies a volume of 450 centimeter cube at a temperature of 14 degrees Celsius and pressure of 0.9 atm. What will be the volume at temperature 28 degrees Celsius and pressure 1.8 atm? So right away we can write that 450 centimeter cube is V1, 14 degrees Celsius is T1, 0.9 is P1, and we are asked to calculate V2, that is the final state of the volume when the temperature T2 is 28 and when the pressure P2 is 1.8 atm. So that's why the equation P1 V1 by T1 is equal to P2 V2 by T2. So with this equation we can calculate V2. So the first step is arrange the equation in such a way that V2 is the subject. It comes to the left hand side and the rest goes to the right hand side. So we can write this expression as P2 V2 by T2 is equal to P1 V1 by T1. So since the P2 is in the numerator, when it changes side it goes to denominator. T2 is in the denominator, so when it changes side it goes to numerator. So we can again rewrite the expression as V2 is equal to P1 V1 into T2 divided by T1 into P2. Now let us rewrite the expression as V2 is equal to P1 V1 into T2 divided by T1 into P2. So before we replace all the values, let us convert the temperature T1 and T2 from degrees Celsius to Kelvin. So we do that by simply adding 273 to the degrees Celsius. So 273 plus 14 gives us 287 Kelvin. And for T2 also, we'll simply add 273 plus 28 will give us 301 Kelvin. Now let us replace the values. So P1 here is 0.9 atm times volume is 450 times T2 is 301 divided by T1 here is 287 into P2 is 1.8 atm. So with this we get the volume as 235.97 meter cube. So this is our V2. Now for the practice problem, I want all of you to turn to page number 12 and try to solve question number 1. So to recapitulate what we have learned under the combination of Boyle's law and Charles' law, which is also called gas equation. We learned the expression, the relationship between volume, pressure, and temperature, and we have also derived gas equation, and we also solved some numerical problems by using this expression, that is P1 V1 by T1 is equal to P2 V2 by T2, which is called gas equation. So with this, we're done with gas equation.